All right, so welcome friends. Welcome to our evening robotics engineering virtual open house. We have some really cool friends with us, but we're gonna give everyone another minute or so to log on, and then we'll get started in a moment. All right, it has been a full minute, so why don't we go ahead and get started? I'll start here. My name is Michael Myers. Yes, Michael Myers. I am an admissions counselor here at WPI, and I work on the Diversity and Outreach Initiatives team here. My pronouns are he, him, his, and I will be around in the background to answer any questions, and I'll be available also at the end. But we have some awesome friends here from the Robotics Engineering department, and I'm going to pass the mic on over to Professor Ken, who will then introduce the rest of his team.
Okay, well, great. Well, welcome again to the WPI Virtual Open House here for robotics. I'm Ken Stafford. I'm actually a retired professor, but I've been involved with the robotics since before it became a program. So I'm really happy to be the talking head for today, and I'll be the one giving the briefing, but we have several other folks here that are a little more high-powered as well. Let me start by introducing our current department head, Professor Jing Zhao. If you'd like to say a few words there, Jing.
Yeah, thank you, Ken. I'm very happy to be here and welcome everyone. I hope you will really find the information presented in this session useful and consider coming to WPI. Thank you.
And then our department, our associate or our deputy head, I guess you call him associate head, is Greg Lewis. So sorry about that, Greg. I'll figure out your title exactly, but
hi. Yeah, hi. I'm Greg Lewin. I'm the associate head of the Robotics Engineering department. And along with Professor Shao and Kalina, we'll be answering questions in the background. If you want to type them in while you're listening to Ken give his talk, we'll be happy to answer questions if we can.
And speaking of that, we were really fortunate to have a junior student in RB here with us. Kalina, introduce yourself.
Hi, I'm Kalina. As Ken just said, I'm a junior RBE student. I'm also in the BSMS program, which means I'm doing my master's degree as well. And I'm a member of the Robotics Club. So I'm happy to answer any questions about those and other topics.
Well, excellent. Thank you very much, guys. And so I'm going to start off this briefing, and again, as Professor Lewin said, if you have any questions, just type them into the Q&A, and we'll try to real-time answer those. But if you have questions at the end, then we'll all be available to answer those as well. So again, I wish you were all here. Campus is beautiful this time of year. Fall colors are pretty spectacular. If you're not used to New England, it's really worthwhile coming out here. But if you were to come here in the spring, you would see the blossoms and flowers all bloom and fountains running, and it's really quite a beautiful campus. A distinct feature about WPI is that we have a lot of technology. In fact, it's been argued that maybe we have, I don't know, one robot for apparently every 3 students. And so you can join that group if you want to, if you come here. It turns out that maybe not everybody has a robot with them, but we have an awful lot of robots on campus. In fact, there is this focus on campus. Our president, in fact, when she first arrived here, said that she wanted to convert Worcester into Robot City, USA. And of course, the focus of that would be WPI. But I want to introduce you to some of the new capital investments on campus, just since you're not here. One of the ones which is really gorgeous is the new Sports and Recreation Center, which is right across from the quad. You know, it seems new to me, although it's 9 years old now. The next building is a gorgeous building, again, adjacent to the center of the campus in the middle of the quad, and that's called the Innovation Studio. And it's just a remarkable building with all sorts of high-tech stuff for doing projects and maker space and some other interesting places as well. The newest building that was coming up academic-wise is the Smart World building. And this is, of course, is an artist's perception, although it's actually built now totally. In fact, I think that I saw the lights are on it now because it's going to be coming up on speed in just a few months. Now, the reason why I highlight these is to show you the commitment that WPI has toward robotics, because every one of these buildings, this is the Sports and Rec Center, has space dedicated for robotics. In fact, this is the 13,000 square foot area under the Sports and Recreation Center, which is designed just for pit space for tournaments. We run a lot of tournaments at WPI. Some of those of you that might be associated with FRC might notice that these are FRC robots, but we also use them for VEX and for Legos and for NASA robotic challenges, this pit area, which is really quite nice. Within the Innovation Center, and is the Innovation Studio rather, is our dedicated undergraduate teaching laboratory. We are the only department that has full-time, engineering department that has full-time occupancy in this brand new building. This is where the freshman, sophomore, junior, and well, all the undergraduate, mostly undergraduate courses, the lab courses are being taught. The new building in the smart world is where Professor Zhao is going to lead the move, because the entire department is moving there. This is the newest building on campus. It will be when it opens up in December or January, I believe it's when they're actually moving. But that's where the department will be. So WPI has got a lot of robots, and all the new capital investments include robotic engineering as a principal part of it, which is pretty cool. But we look back on robots in general, and back when I was your age, as robots were really exciting. They were very, very cool. It was something new and thrilling, and not very many of them. There was one that I remember seeing, but that was basically it. They weren't really out in the world, but you kept thinking about this is the future. And in fact, what happened is that in 1965, WPI recognized the need and the future of robotics. And so we developed the very first robotics lab on campus in 1965. And these are the kind of robots that were being implemented and tested. These were industrial robots, very important then, still very important now. Virtually any car you've driven in the last 60 years has been largely worked on with robots like this. But again, this wasn't the robot that really set the academic world on fire. It was little small robots like this. And of course, this is the Roomba, of which there's been, I think, like 20 million of them sold now. This is a little vacuuming robot that I personally have, I think, 4 on my house in my house right now, which is pretty cool. The cats really like them. But this was interesting, because this is the first time that robots really became in people's homes, people that recognize them being robots, that is. And they're becoming better and better all around. And so it was not too much, it was actually about a year before this, in 2001. This 2002 is when that Roomba first came out. But in 2001, the same company, iRobot, came out with the PackBot. Now, the PackBot initially started out to be a defense project, but later on became more and more useful, and they've used them for security and lots of investigation stuff. They became kind of the utility robot that could go anywhere. In fact, one of the first uses was in the 9/11, exploring the rubble for survivors during the 9/11 attacks. They used actually one of those robots. And then once this robot got established, robots started showing up in almost every kind of environment you could think about. They were all over. And it became so compelling that we decided it was time for us to get involved with that. And so that's what happened. In a really, really interesting and innovative step, WPI became the first university in America to develop a robotics engineering program. And you can see when it started, and we're about 14 years ago, it started. And then we quickly added graduate degrees upon that. In fact, today, I just got some briefing, and our graduate program is just growing hugely. In fact, there's almost as many graduate students now as there are undergraduates, which is really quite surprising. But we were the first institution to offer it, an undergraduate program. And of course, now we're the first to offer all of the degree options that you could have with robotic engineering. It was a risky move on our part, because people at other schools had said they were going to do it, but no one really got around to figuring out how to do it. And so when we did it, we were anxious to see the results, as was the Accreditation Society. And so it was really quite rewarding for us when we had our first graduates and asked for accreditation. They came in and says, well, we'll see if you can do it, but no one had been able to do it yet. And we were fully accredited. Now, the interesting thing about that is it means now that there are accreditation standards established for robotics engineering. And so any of the schools that kind of follow in our lead, which there have been a few, are kind of compelled to follow the same things that we had established as being the way to teach robotic engineering. But it was a risky and a very complicated and took some really creative thinking to get it developed. And it was so innovative that shortly thereafter, the Accreditation Society actually awarded us with their very first ever innovation award. The first time they'd ever recognized any university for really an innovative program. So we were really excited about that. And that was reflecting how excited they were about our program and how successful we had been. So we're pretty pleased about that. But if you look at the robotics industry in general and how to accommodate that, we started out by inviting some of the big hitters, the big players in robotics nationally and internationally to become part of an advisory group for us. And one of those was Helen Grainer, who was of course one of the co-founders of iRobot and Sci-Fi Works and a few other things. She's really quite a talented person. And, and she said, basically they're Silicon Valley, but we are the epicenter for robotics. It's really New England. And so last spring, I did some research and found out that in the Boston area alone, there were over $2 billion worth of robots sold last year. And you can look at the number of companies, 52 different robotics companies listed in Boston. And it's a new endeavor because 47 of them have happened since we started our program. And of course, they're hiring. And in fact, again, as of April of 21, last time I talked at, there were still 135 open slots. So the jobs are up there, and you can see what the average salaries are, not too shabby. But not everybody that has robots even know they do. These are the places within New England that know they have robots. But there's a lot more companies that have them that don't really understand it. But you can see why it is called the epicenter of robotics. They're just all over the place. But globally, it's not much different. Again, in 2020, there were $24 billion worth of robots sold. You can see the number of jobs worldwide, 150,000 available right now. But most significantly, in business journals where they've investigated the strategic plans of all global companies, 88% of all global companies have listed automation and robotics as part of their long-term business plans. So it's a lucrative place to get in there, and it's the right time. So when you think about robots, there's Robbie the robot, and there's other things that could be robots. And one of the interesting questions that came up when our very early advisory board meetings was that we really need to define what this is going to be, because some universities think that robotics is really just the artificial intelligence. Others think that just some complicated mechanisms, remote control mechanisms. And so we tried to figure out what it is. And all of these things here could be called robots, but we weren't clear, what they are. And in fact, anecdotally, during one of the lunch sessions of our advisory board, I think it was the very first advisory board, this question came up, and everybody's wondering, what is a robot? And the one answer which resonated best was that, well, they're hard to describe, but you know one when you see one. And somehow that's not very satisfying to form an rigorous academic program around, because not all these robots look the same. And so we decided to have a little bit better definition of that. And so here's what, if you study robotics at WPI, this is what you're going to be dealing with. You're going to find something that, first off, has sensors. It must be able to observe in some manner its outside surroundings. And then, very critically, it has to make some smart decisions about it. It has to make some computations. And then once it does that, we want it to do some physical action. This defines it from being not a computer game, but a real situation. It has to be a physical action, which is in the actual environment. It's not a simulation. This is in the actual environment. And then the final thing here is that the robot should be smart enough to have feedback, to know what it was supposed to do and what it did do, and resense that. And so this is kind of what we started this program out. Now, Professor Zhao actually had to simplify it. Some time ago, I was talking to her, and she said, well, it's really just this, Ken. It's intelligent connection between perception and action. So if you can envision a system that does something to observe and then make some smart decision about it, and then observes what it's done, well, then that's a robot. So those are the sorts of things that we wanted you folks to be good at. Now, those sorts of things used to be all defined by what was called the 3Ds. Perhaps you've seen this, maybe you haven't, but robots, when they got started, and especially in 1965 in that era, did one of three things that were too dull or too dangerous, or frankly, just too dirty for people. That was called the 3Ds, but that thing has changed remarkably over the years. If you think now, about the sorts of things that are enablers that make robots powerful, they include these sorts of things. Sensors, devices, actuators, communications, all this sort of stuff is what comes together to make a robot really capable. And what has happened with these devices? It was about, I guess it was about 15 years ago, one of the first robotic challenges that I got involved with was advising a team that was building a automated car for one of the DARPA challenges, the grand challenge to drive a car 300 miles across the desert totally autonomously in Southern California. At the time, one of the high-tech sensors you need to have was what's called a LiDAR, which is looks like a rotating beacon really fast on top of cars. You'll see them on a lot of experimental cars. And these are laser-based time of flight sort of indicators, which will give you an entire perception, 3 dimensions about what's around you. And they're very, very capable. But at the time, they were around $15,000 a piece. The same company now that made that now makes one which is solid state that sells for $100. So what's happened to all these sensors is that all these things which give you great capability have gone down drastically in cost over the last 20 years. Now, who's needing these robots? Well, it used to be, automotive industry. And then some other people started using them. Pretty soon it's more and more and more. And now you can look at this area and you can see that basically every community and every industry is looking for automation. Especially in times like COVID times when you would like to limit human-to-human contact. There's lots of healthcare sorts of applications and home care situations that are happening right now, which is really pretty exciting for robotics to happen. So what's happened is that as the costs have gone down, everybody's need has gone up. This is really a really sweet time to be involved with robots because it's the perfect storm for us right now. Why WPI? Well, if you think about robotic engineering, it really is fundamentally a combination of a bunch of stuff. Because you have to be, you're a specialist in robots, but it means you have to have these skill sets, which are both mechanical, electrical, and certainly computers. And in fact, there's a kind of a fourth discipline here, which is knowing the right tool to use for the right situation, which is called systems engineering. This is what is we think is required for robotic engineers to be successful. And of course, because of the fact that robots are a real thing, then there has to be a lot of experience also in actually building real things. It's a practice of developing robots. And finally, as we've earlier mentioned, everybody wants robots, so you better know what they want. You have to have really close industrial connections in order to define your program to meet the needs of today and tomorrow. So WPI was founded upon these same principles. The motto of the school is Lehr and Kunz, which really means theory and practice. But we've also been, we were the school, one of the very first schools to ever go with a full project-based curriculum, which really combines a lot of hands-on work. We've always had really close relationship with industry giants to help define our programs and help generate projects for our students, in fact. So we really have we had the right juices to make a really good foundation for robotics engineering. And it didn't hurt rather, that we also have literally decades of experience with some of the real feeders into robotics development. Obviously, beginning from the time that Dean came and was a student at WPI, all the way through the point that we're a legacy team with FRC. We sponsor FLL, we run FTC tournaments. We started with VEX before VEX became VEX. If you go into our into our academic labs, you'll see we use a lot of VEX equipment in there. So we have all this, plus we've won and been related with NASA for quite a bit of time in robotics. In fact, anecdote, I'm wearing right now a shirt that this has to do with the NASA sample return robot mission. In 2012, actually 2011, NASA came to us saying, hey, listen, WPI, we know you are keen on robots. We have this new robotic challenge. We would like you to host our Centennial Challenge. And it was really quite a stun for us because NASA had never asked a university before to host a Centennial Challenge and never had any Centennial Challenge even hosted east of the Mississippi River. But they said, we want you guys because you guys know robots and we want to have credibility when our international competitors come for that. So we ran that tournament for 5 years. So NASA knows a lot about our robotic experiences. We look back on the year before we started the program. As I said, we did have a robotics lab. There was one course, one lab, one faculty person who taught it. And of course, there were actually no robotic students. There were students who were mechanical or manufacturing engineering that took that course, but there were no robotics students. So today, oh, and by the way, obviously no program or degree. Today, and frankly, this is a moving target. We get more and more courses, more and more faculty. The core faculty goes up and down, but we're building all the time. More and more students, and of course, we have all of the degree programs that would be appropriate for it. Also, of course, because we just recently, this year, gained full department status. That puts us in the first time in America. Then we have terrific respect from the people who actually understand it's not just NASA, but also any other big government funding agency that wants to fund our research and our projects. They're all here, and they are frequently looking for us to do work for them. So we've progressed quite a ways here. And now, since I'm talking to presumably an a high school audience, I will tell you that right now that probably about half of you, if you're a typical audience, will have had some robotic experience in high school. And so I'm going to just go down a little few of my favorite robots that we've had at WPI that may or may not resonate with you folks. This is the 2007 World Championship at Epcot Center. And actually, this may have been in, this probably was in Georgia, Atlanta. But anyway, the WPI sponsored FRC team, 190, was the Lions captain on the world champion team. This is the very last match of the World Championship on Einstein Field, and 190 is the one holding up our teammates there. So we had some experience with first FRC. I'm always happy to talk about Savage Soccer, which if you're from New England, you may have heard of. If you're not, you would have never heard of it. Probably, but Savage Soccer was a student initiative, a WPI student initiative in 1998 to establish a very low cost, affordable, but nonetheless compelling robotic experience for high schools. And so we have run that thing since '98 every year. It is cool in that every year the game is designed by WPI students. The event is run by WPI students. And we've run it, and we've had sometimes as many as 200 teams show up for this. At one time, we had clones of Savage Soccer. We had Savage Soccer West being run in California. We had a Savage Soccer being run in Kansas, a Savage Soccer being run in New Hampshire, and one in Connecticut. But the Intergalactic Championship has always been at WPI. So it was a cool student project, which shows you the kind of things that students can do that started out to be an academic project, and now it's just a fun project for them to flex their robotic muscles. Talking about robotic muscles, robots come in a variety of smarts. It's kind of like sumo wrestling versus, I don't know, Olympic wrestling. This, of course, is Bite Force. For those of you who ever watched BattleBots, and you'll notice it's got WPI all over it. It's a three-time world champion with BattleBots. And the reason why I put it on here is to show you that, we're interested in robots of all types, but more particularly, that same student, Paul Ventimiglia, who built this, also built this robot while he was a student at WPI. He was my advisee, and I let him use part of my lab space to develop this robot, which was called Moonraker 2. And it also went to a NASA Centennial Challenge in California, and he won it. It was a regolith excavation challenge to harvest simulated lunar soil and it was a very interesting challenge. You were allowed to use remote control, but you had to experience the time delays that would come from the 2-second back and forth time from the world to the moon. And NASA had tried to give the prize money away for a couple of years. No one had done it. So Paul built this robot, and he walked away with a $500,000 prize. It was quite an exciting thing for a sophomore to come up with. Another NASA challenge that we came to, and again, NASA invited us to compete with this thing called Robo-Ops. And I mentioned this one here because you'll see there's two students and myself on this thing. We were sitting on one of the hills in the rock yard at the Johnson Space Center in Houston, Texas. That's our robot that the students built. What you don't see here are 4 other students who are still on campus at WPI, because the challenge of this mission was to find and scoop up these little colored rocks. You see, we're holding 5 of them there, and then load them and bring them back to a location. As you can see, we're touching that little blue plank there. Had to come back to the base to do that. And the only rub was that your robot had to be fully controlled from your home university. And so we were controlling this robot from 2,000 miles away via 3G connectivity. And they only allowed 10 schools to compete. And we won that first year quite handily with this robot. And then the second year, there were 10 more schools that were selected. We were selected again to go, and we won it again. And the third year, NASA came and nudged and said, you know, could you let someone else win? So we came in second. I think Caltech came in first the third year. But I want you to look at this robot, and then later on, I'm going to show you a follow-on for this robot, because this team who won this bid, we're doing this project totally with no academic onus. It was just a fun project they wanted to do, and that's the nature of WPI education, is that we want you to be active and involved. And so we fully support it. I flew down there with them, and we won it. This is another robot that involves students from every age group. We had students from freshmen through postdoctoral students working on this project. This is an Atlas robot. You know, this is a 300 pound, 6'4" humanoid robot, and he made it into the finals of the DARPA challenge to operate in a contaminated, like nuclear power plant disaster. And so here you can see him walking through rubble, and he had to drive a car and turn a bunch of switches and stuff. And he did very, very well. I think there were 12 universities that made it to the finals. We were the only robot that never fell during the whole period of time. So that was really quite good. For those of you, again, in New England, you may have heard of Battle Cry, and I mention it because we've been doing that for 21 years, and this is arguably maybe the most popular high school robotics tournament, you know, in America, and that we normally have 60 teams, and it fills within 8 to 12 seconds after we open the registration gates on the web. And so that's been a fun thing that we do. A personal favorite of mine is, and again, it displays the sorts of things our students do, because students came to me about 6 years ago saying, hey, we heard about this new competition, which is called Robo Sailing, you know, and can we build a robotic sailboat that can compete? And so we went to international competition, and the first year with this group of freshmen and sophomores, 1 junior, and we came in dead last. The next 2 years we competed, and we came in dead first. We won the international sailboat contest 2 years in a row, and we continue to compete in that. It's a lot of fun. I think it'll be in next month. If you're watching BattleBots, you will see this team on BattleBots. Now, this is unlike Paul Ventimiglia's Byte Force, which is, you know, he is an alum of WPI. These are current students and really recent alums of WPI that have built Ribot. And Ribot, you will see Ribot in the current series of BattleBots coming up. I think they're going to start showing those issues, I think, next month. But it's, again, non-academic, but fully supported, because it's really hands-on robotics. It's really way cool. So here's how we get people to those kinds of capabilities. This is the way the course is set up. We do have intro courses. The intro course is really going to touch upon the fundamental disciplines, but also very important intro course is our Robotics 1001. It's really a popular course, and we recommend everybody take that the freshman year if you can. Then we get into the core of how we get all of these disciplines intertwined into this one content. That's called our unified robotics, and that is a four course sequence, which normally goes over your sophomore and junior years. And that would give you all of the intermediate, sort of robotic knowledge, you know, up to the point where you're actually now doing path planning and really smart perception and do some really complete robotic work. But then the end of the program, there's all sorts of rooms for advanced courses. We actually allow you to take advanced courses in any field of science and, design and engineering, whether it's in biomedical or architectural engineering, civil engineering, basically any kind of engineering you want to, that you could apply your robotics knowledge to. And then of course you end up with a capstone project, which is way cool. Here's just a list of the sorts of undergraduate courses that are available. There's a bunch of these which are deemed experimental, because we have professors come in, they want to teach a certain course, and so we try it for a year, and then we see if we like it, and then students like it, then we'll make it a permanent course. But these are sorts of courses that you can see. They're there. These are intermediate through some advanced courses. But talking about advanced courses, we also have these courses available. Now, those of you who are kind of keen on the way most universities number the courses recognize the 5 in here, saying, well, those must be graduate courses. And the answer is, yeah, they are. But WPI plan does not prohibit undergraduates from taking graduate courses. And our policy is you take a course when you think you're ready. And so we have quite a few undergraduates who actually take some of these other courses. And so they're really quite excited about that. I display here just a little bit of a typical schedule. We do have 4 academic terms per year, which you probably know. And I've highlighted here in yellow the courses in which you will actually build robots or robot parts for sure. And so this is not a promises curriculum. This is not one of those courses, these courses where you say, take this, we promise you're going to need it. Because you'll be taking courses and then you'll be using them real time to build stuff, right away. And so this is really a hands-on operation. I'm really pleased about that. Look in the last half of this, you'll see all the room for electives. These are places for you to modify and get your program just the way you like it. We're really pleased to be able to offer that. The capstone project is really what's the cool thing. But now, those of you who are applying for, you're all applying for WPI, or at least interested in it, and you're probably looking at other schools as well, and as you should. And you'll see that a lot of other schools do offer robotics of some sort. Most of them don't offer a degree program, but there are some, there's a half dozen or so that do have a degree program. And so look at those and see if it fits you, because our style is quite a bit different. But the main thing, my point here is that, and I don't want to step on admissions toes here, but as compelling as I think robotic engineering is at WPI, to my mind, it's not the reason to come to WPI. The reason to come to WPI is because of the way the policy of the entire school is, and it's called the WPI plan, but it really is distinct among other universities. And so I challenge all of you, I really think you should really make sure you understand the difference between the way we teach undergraduate students and the way most schools do. It's quite an eye-opener the way it works out. But so I challenge you to learn that. We have lots of sponsors. Everybody likes to put their name on robots. Robots are expensive to build. People like what comes out of WPI, so they're willing to donate a lot of stuff for us, and we get a lot of good support. We also, our capstone, you can see these are student projects that have been built. Some of these are way old, but there's one I picked here I want to show a little bit. This was the second version of that Robo-Ops competition. And now this is the same group of students who won it the previous year, but this year they did it as an academic project, and they built a much, much more sophisticated robot. This robot was totally built by the students, everything from the design through the manufacturing, through all the simulation. When we first showed this robot off to some NASA people, said, okay, what part did the students do? We said, oh yeah, they did the chassis, yep. And they did software, and they did the wiring, and they did all of that. And of course, they worked pretty fast. Now, interesting enough, all 4 of those students did come from high school robotics. It turned out they were all from FRC, programs. But this robot was designed to be an extraterrestrial robot simulator that could go lots of places. But also it had to be, it was designed to have a chassis that would be modified to put any sort of accessory you want on there so you could experiment with different things. Here it's putting on a camera tower and also hooking up a communication device. So now, by virtue of that pan, tilt, zooming camera and a cell phone connection, it can be driven by someone on the left over here from anywhere in the world. And of course, that's the way we did take it to Texas and won again. We put on a scoop with another bucket on there. And of course, these people who support, and of course, wheeled robots can't climb stairs. Well, I guess if you have a clever chassis, they can climb stairs as well. So I like to highlight that. That just turns out to be one of my favorite robots, and it does kind of capitalize what the best of our projects ends up being. Our folks get hired by just about everywhere. Several years ago, we had kind of an awkward circumstance happen when Google and Apple came on the same time on a special recruiting tour at WPI. And I was talking to both the Google guys and the Apple guys. And I said, well, what are you here for? And they both said in the same words, we will hire every single robotics engineer you can provide. And of course, why Apple? Well, that was the time when Apple was going to build their Apple self-driving car. And of course, Google was interested in the same thing, self-driving cars. So anyway, that's my pitch. And I don't know if there's been a bunch of questions that have been asked and answered already, but we have lots more information on the site here. And I will now leave it to Mike to see if there's any more questions that we can all answer. And I'll stop my share here so we can get back into bigger pictures of us. Mike, are you there?
I'm here, just waiting to see if anyone puts anything in the chat.
Oh, okay. If you're still there, don't be shy. Especially, I would suggest that as long as Colleen is here, you have a chance of talking to a student who's interested not just in the academic part of WPI, but also, as you may recall, she was part of the Robotics Club. And for those of us who love WPI, understand that one of the real resources at WPI, which you should have got through my briefing, is the fact that it's not just about academics, it's about experience. And we provide academics, but we also allow you a lot of resources to do a lot of other really cool things.
Awesome. So thank you. We have a couple of questions that are starting to come in. Excuse me. So Alex would like to know, what guidance is there on choosing a major qualifying project? And while we're at it, why don't we also answer what robotics engineering students typically do for their IQPs as well, if there is something that's typical.
I can start that, and then Colleen, you should probably talk about what your plans are. But in terms of the major qualifying projects, they come from three sources. Oftentimes industry will come to professionals and say, we have this real problem, can you assign some students to fix it? So maybe about a quarter to a third of the projects come from outside sources that really, they have a real problem, and they understand we're gonna fix the work for them, and it's great. Another third or so come from professors' own research interest. You know, they will come from, you know, maybe some professor just wants to do some humanoid robotics like this and says, okay, I want to get a team to do some real bona fide research from that. And then the other third come from what I think is one of the coolest thing, is that students like Colleen and others would get together and say, you know, what do we have in common? What do we like? And so they will get together and form their own concept, a piece of paper. And they'll send it, who do you want to advise us? So they'll find some advisor, and they'll find some chump like I don't know, like Greg or myself that have difficulty saying no. And they will have something that is appealing to us. And so we'll say, yeah, form it up into a little more proposal and we'll figure it out and we can do that. IQP wise, IQPs are supposed to be outside of your major. It's supposed to be something that shows that you can use the skill sets you have in a way you didn't expect in social research. So don't think you're going to do a robotics project in your junior project, although some of them are. Kalina, do you have things to say about that?
Yeah, so I haven't figured out my MQP yet. That's definitely something I'm going to be doing this coming term in preparation for my senior year. But I actually just got back from my IQP. I went to Montana for a term. I worked in Glacier National Park, and I did a vision mobility analysis project on it's like data analysis on all of the visitors that they have there. So for an example of an IQP, there you go.
I will tell you that I'm scheduled right now to go to Namibia, Africa, to support 6 teams doing IQPs. And one of the projects there is to develop a robotics curriculum for middle school and high school students. And so we are developing a high school curriculum for robotics in Africa. But that's interesting because only one of the students on that team is a robotics engineer. The rest of them are mechanicals and software and all that kind of stuff.
Along that same vein, is there a major or a minor that's commonly paired up with robotics that you find?
Yeah, actually, robotics engineering students tend to also have a second major in either computer science or mechanical engineering or electrical and computer engineering. That's very common. And some of these students in those departments also may have a robotics second major in robotics or a robotics engineering minor.
Yeah, I used to have, traditionally, I would have about 70 undergraduate advisees. And of those, generally speaking, about 30 of them would be double majors. In my case, since my background is aeronautical and mechanical, their double majors would normally be in mechanical or aero with robotics. So it's not uncommon, because a lot of students come here with advanced placement credit. And there's a philosophy at WPI about getting more in 4. And so if you have like a half a year of credit, then get more done. Get 2 degrees. Do a, like Kalina, you're doing a BSMS, right? But not in 4 years.
Yeah. So I came in like debating double majoring in mechanical engineering because that was my stronger background coming in. And then I decided pretty quickly on that I just liked everything. So I'm going to focus on getting my master's degree while I'm at it instead of double majoring. But plenty of people do double major. Like if you have a really strong preference for mechanical engineering or for computer science, you can get 2 degrees. I know plenty of friends that have done that, and in 4 years too.
Awesome. And then Madeline asked, I know we did speak about this a little bit, but would CS be a major that you would see around the robotics department as something that it's coupled with?
Absolutely. Yeah. I have a lot of friends that are a double major with CS.
Awesome.
Very common.
And so in the admissions process, I know lots of students tend to watch our very popular video that actually features robotics, and they talk about that 3-legged stool. And so what are those 3 legs, and how do they come together for the robotics engineering major?
I'll just start this off because it's like we said at the very beginning, the school has a very purposeful balance in those 3 legs. We really strive to have equal emphasis on what we consider are the things that hold up robots. And one of those is strong mechanical engineering skills. One of them is all the electronics, the communication sensors, which is electrical engineering bits, and including some embedded controls and this kind of stuff. And then of course, it all has to be smart. And so that's the computer science bit. So those are the 3 competencies that we really strive for all of our students to do that. And Kalina, have we succeeded with you? Do you feel like you're competent in those? Say yes.
Absolutely. Yeah, I love all 3.
The truth of the matter is that we do believe that all students will have a bent toward maybe programming or mechanical or electrical. However, to get through this program, you have to display competency in all 3. There is no way you can't just slide by and say, I'm really a CS person, but I'm going to call myself a roboticist, because you will find that you will not be successful. You really need to have those competencies. Then you can advance one element of it or not, depending upon how you feel about it. Unless you're totally balanced like Kalina is and wants to be good at all of it.
Yeah, I'd like to say coming in, like I didn't have any computer science or electrical really experience. All my experience was mechanical, and everything that I knew was mechanical. But going through all of the classes, I've learned everything I needed to know so far about all 3. So.
Awesome. And the last, one of the biggest questions is, if you were a prospective student, and I know, Kalina, you just made it through that process a couple of years ago, what advice would you give to our prospective students today?
It's a tough question. I guess, I don't know. When I came into WPI, I didn't really know for sure that I wanted to be a robotics major. Like I said, I was very focused on mechanical engineering at the time. But if you're at all interested in robotics, this is a very good place to be. There are a lot of other schools I looked at that had like a minor, or they also had a major, but they were like working up to it kind of. WPI definitely has the most resources, the most faculty, if you're interested in doing anything robotics.
And I'll remind you that the homework that I would give you in being prepared for universities, whether it's WPI or not, is try to understand, get a feel for what the core of the university, the philosophy of the university, the teaching philosophy, the student to faculty interaction philosophy, and see how those differ from school to school. Because like Kalina said, is that you don't come here, you say, I'm going to be a robotics engineer. We don't demand that. In fact, there's no requirement to list any major when you come here. We want you to be smart and make a decision based upon early experiences, maybe the first semester. And that's our goal, by the way, is do that. So it would be disappointing if you came to this school only because they had this brilliant robotics program and you find out in 6 months that really I'm a computer scientist. However, if you came here because the way the school operates and the student to faculty interaction and the resources that are available to you, then that was a very smart and wise decision, I think. Could be biased.
I think we all can be, right? It is really an awesome institution.
My daughter graduated from here, so I know, I've seen what it happens to people, and I've been thrilled by it. So.
And from our other two, is there anything lastly that you would like to add, my friends, before we close out? All right. So I will drop my contact information into the chat, so feel free to grab that. And as you all go throughout the next couple of weeks and complete your applications, I know November 1st, our first deadline is coming up for our round 1 applications. If anything at all comes up, or if you would like to speak with any of these awesome people on the screen, contact me. I'm more than happy to put you in contact with them so that we can answer any of those last lingering questions that you have. Otherwise, if you need anything, feel free to reach out to me too. I'm more than happy to work with you. And I hope you enjoyed your time with us. Thank you so much to our robotics engineering department for joining us this afternoon. And I can't wait to see you all in B-term. Awesome. Have a great evening, everyone.
Bye-bye.
Bye-bye.
Bye.